Welcome to the Stormsurf video surf forecast for the week starting Sunday, January 3rd. Looking at significant wave heights for the North Pacific Ocean, we see a very active pattern. A small gale off the California coast, already generating 26-foot seas. A far larger remnants of a storm still producing 40-foot seas aimed well at the U.S. West Coast with sideband energy towards Hawaii. And yet a third system developing off of the Kuril Islands near the dateline. This is the pattern that is set for the coming at least week, if not much more beyond, with the active phase of the MJO fully in control now, and the North Pacific jet stream roaring west to east. Let's get into the details. First, we'll take a look at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when those gales form, do help to direct their track. Currently, we have a pretty good flow set up here. That is, running from west to east on about the 35 north latitude. A little bit of a split here off the U.S. West Coast, but that will be short-lived, and good amounts of energy right here near the split point, and generally a cohesive flow throughout the width of the jet here. This pattern, the way you see it now, is very similar to what it would look like almost a week from now, too. This is all supported by El Nino and the active phase of the MJO having the desired influence on the jet stream. So here we go. Winds coming off Japan in the 130 knot range, building here with a nice trough that is a dip in the jet right here, supporting a counterclockwise flow aloft. That is the sign of low pressure. That also manifests itself down at the surface. That provides fuel for storm development. Then we have this split here that's setting up high pressure over the U.S. West Coast, providing a modicum of protection, but that is expected to be very short-lived. Let's put this into motion. As we roll into Monday, you see the split disappear. The jet basically comes roaring onshore, 140 knot winds, move very far to the south too, pushing into Southern California. New pocket of wind energy builds over Japan, starts working its way there, 190 knot winds by Tuesday. New trough starts digging out here, and then you sort of have this little bit of a cutoff here, but a big trough kind of set up here over the U.S. West Coast. All this means is a parade of storms expected. 200 knot winds by Wednesday night. Big trough, another storm likely in this area. And we got a little bit of a split setting up here, but this sort of perpetual trough-like thing going on over the U.S. West Coast. More manifest there. Still a split there. But as we roll this out, you can just see more wind energy building in the jet. It just looks like it wants to just dive here and just make a massive trough, plowing into the U.S. West Coast come the weekend. And more or less, it kind of does that. There's little bits of a split here. Now you get 180 hours out, and we have 140 plus knot winds over about half to two-thirds of the North Pacific Ocean. The jet very healthy, rolling into Baja. This just looks like a perfect setup for a parade of storms or gales. Not necessarily super well defined, but probably a lot of weather for the U.S. West Coast. Not so great for surf, but if you're trying to build a snowpack, if you're trying to build water into the southwest U.S., this is the way to do it. Next, we'll go down, check out surface level pressure, surface level winds. As expected, good strong gale here in the Gulf of Alaska, 45 knot winds, a little teaser gale. This front right here just starting to work its way into California. This is sort of the primer. This is the leading edge of what is to be the parade of storms. We already saw seas associated with the, 35, almost 40 knot winds right in this area off the U.S. West Coast. That's the teaser system. Stronger gale here, the remnants of what was a larger storm, and we'll get into that in a minute. And then the next system developing over the dateline region. We'll just put this into motion. You can see the former storm disappearing in the Gulf, the one that was up here, working its way into the Gulf, building some, working its way towards the U.S. West Coast, while yet another system builds over the dateline region. Again, lots of weather looking to be moving into California into the Wednesday time frame. That rolls through. This system here doesn't get good traction. It actually ends up rolling up into the North Bering Sea, but more energy behind it. Also notice what appears to be tropical activity. We don't necessarily believe that come Friday, but we'll roll this out anyway. Another front approaching the U.S. West Coast come Saturday. Another storm developed, 55-knot winds, and yet more activity off of Japan. We'll just keep rolling this out. Now, a little bit of a stall here, but then another front sets up come Sunday night off the U.S. West Coast, and here we are at 180 hours, and it's just a machine, basically, with the jet just driving the flow the whole time. Very good for stirring up the sea state, very good for creating large surf, very good for creating weather, but in terms of clean surf, not so good. Maybe Hawaii has the best shot, but even at that, it's very close to where all the storm activity is. What is that? 600 nautical miles away. So generally, a confused sea state is what is expected. Let's take a look at significant seas, that is total significant wave heights for the North Pacific Ocean, the result of winds. And as we saw before, 26-foot seas already off the U.S. West Coast, California specifically, 40-foot seas in the Western Gulf, and the new system developing here east of the Kurils. Before we get into the forecast, though, we're going to take a quick look back in time. Specifically, this weekend, a storm started developing here on the dateline, 06Z on Saturday. Put this into motion. You can see already 39, almost 40-foot seas right here on the dateline Saturday morning. We'll just roll this out here. And it built into about there Saturday night. That was 45.7, let's just say 46-foot seas right there. Now notice most of the energy was heading straight to the east. Sideband energy only towards Hawaii. But we'll roll this out, and then we got, what was that? That was... there was a solid 46, almost 47-foot seas on Saturday night, and then the system started fading from there to where we are right now. The result is swell is in the water heading for Hawaii and the U.S. West Coast. And you can actually see it here. Watch just right here as this treks through. You can see the front, if you will, the sea heights, not necessarily swell, but sea heights pushing into the Hawaiian Islands on Monday morning. A good solid short blast of swell expected for the islands, but most of the energy, as you can see, is clearly moving to the east. Anyway, so here we are Monday morning. This system, originally off California, starting to fade, 18-foot seas, 30-foot seas, still in the Gulf of Alaska. New system developing on the dateline, 32, almost 34-foot seas, building into about the 35-foot sea range, coming and backfilling in behind seas here in the Gulf at 23 feet from the previous system. And then you can pretty much see the front hitting the California coast on Tuesday night, large seas, and another system building in right behind, and actually getting a little bit of help, additional winds, seas in the 35-foot range, basically slamming right into the central California coast on Thursday. Likely very stormy conditions. Another system in the Gulf of Alaska working its way towards the Bering Sea. Just a little bit of a break here. And then here comes our next system queuing up on Friday. Little one and a stronger one back in the Western Gulf by Saturday with 44-foot seas. And that is about the peak of it. And residuals all working their way to the east, being driven by the jet stream. Here we are 174, 180 hours out, and yet more systems queuing up. The issue here is when you get so many storms back to back to back, the ocean doesn't have a chance to calm down. It becomes a very confused sea state. Hawaii, because you say, well, they're not getting direct energy, but at least they're getting probably the odds of something cleaner. U.S. West Coast, this whole area is probably going to be a pretty jumbled mess. Protected breaks in Southern California might do okay, or down into Baja, from just looking at the charts here without going into all the details. Just a real quick look here at a surf graph for North Shore of Oahu, 24-foot seas on, or 24-foot surf on Monday, settling down into Tuesday, only to bounce back up into the 15-foot range early Wednesday morning, settling down, and then back up again to 18-foot range on Sunday. Winds not trades there basically for the most part until you get into the Wednesday time frame. Things get confused, and then trades try to get back in established onto Saturday or so, and then turn back northwest Kona winds. Relative to Ocean Beach in Northern California, we see good-sized surf in the 23-foot range come later Tuesday. These dropouts are actually from there being too much swell, and we filter out wind swell, so it drops it out completely. But you can see just basically a long run of jumbled, probably 20-foot surf, winds in the 20-knot range from a variety of directions. And then winds pick up again on Saturday, swell drops out, but then back into about the 10 or 11-foot range, lots of surf. So let's take a look at the long-term pattern. El Nino 2015, well, it's actually 2016, so I'll have to update that, but you get the sense. Let's see where we're going. So before the Christmas break, we were talking about a lack of westerly winds in the Kelvin wave generation area. That is from roughly about 135 to about 170 either side of the equator. And that was due to the inactive phase of the MJO destructively interfering with the El Nino base state, which is normally right in this area where you see most of the activity. And so basically, the inactive phase of the MJO creates east winds. The El Nino base state creates west winds. The two of those were canceling each other out, and there just wasn't a lot going on. Well, what a difference 2 weeks makes. The active phase of the MJO is now in play here. It is constructively interfering with the El Nino base state, which basically means the two of them are adding together, supercharging it. And as you see, as the 28th of December, we started getting westerly anomalies. And look what it's built to now. Just this massive area of westerly anomalies and actual westerly winds down at the surfaces as of January 1st. Just feeding the jet stream mad with energy now. This is exactly what one would expect to see if we were in a strong El Nino situation. The current image here from the TAO buoy array, these are actual winds, and you can see there's northeasterly winds north of the equator in the Kelvin wave generation area, again mainly here, but you also see much westerly winds south of the equator, and deviations from normal for this time of year suggest all this is the balance is towards westerly winds, is more west winds than normal, all south of the equator, which is kind of a good thing because most of the activity this year has been north of the equator. Now it's south of the equator. This is very much a El Nino supported pattern. So here we are. This is the GFS model, sort of zoomed in just to the Kelvin wave generation area here just north of New Guinea from about 135 west to 180. It actually goes out here to about 170 west, but you get the general idea. Here are the east winds in the northern Kelvin wave generation area. Here are the west winds in the south Kelvin wave generation area, and we'll just put this into motion. What you're going to see is westerly winds. If you think they're strong now, they're going to only build in coverage here south of the equator into Wednesday, and we'll just roll this out, continuing to cover good ground and then starting to lift north here a little bit come Friday and building in coverage into look at this Sunday tropical system. Well, now we don't believe any of this here, but still it's the total coverage of westerly winds here. These aren't anomalies. These are actual westerly winds building nicely into Sunday a week from now. And also notice the easterly winds up here in the north start really backing off. So again, it looks like this westerly anomaly pattern is only building. That we believe is likely due to the active phase of the MJO just getting its roots dug in deep. Typically when you get the MJO, it goes in about 3 to 4 week cycles, maybe longer, sometimes to 6. So we had a 6-week run of the inactive phase of the MJO. The question is, how long will this active phase of the MJO constructively interfere with the El Nino base state? We'll get into that in a minute. So we've seen this chart before. This is a history going back in time, the 4th of December, the Kelvin wave generation area, the area that's really responsible for creating Kelvin waves. And we're not so much thinking about Kelvin waves right now, but this is also the main area we look at for the MJO and it actively supporting the jet stream. And when the jet stream is strong, it helps create storms. When you have storms, that creates ocean or wind down at the ocean surface. That in turn helps create seas, and seas, when they're aimed at you, turn into swell, and that creates surf. So, and also, if the jet stream is strong enough, it also creates weather. So here we go. Kelvin wave generation area runs roughly down here. This is the whole planet laid out. This goes the whole way around the planet, so it's just this little area down here that we're interested in. And right here on about December 19th or so, that's when we broke out of the inactive phase of the MJO, and the active phase started showing up. And we'll just scroll down here and look at this. It started building. When you get into the whites, that part of the scale here, you're up here about 12 meters per second. This is legitimate westerly wind burst territory. Here we are as of today. The forecast only suggests this is building stronger. That's exactly what the GFS model showed. This is a different depiction of the GFS. So basically it says this pattern is just building massively. So the expectation is the jet stream will build with it, the storm pattern will build with it, and probably we're going to see much weather building with it too. Here's yet another flavor of this chart, but it also shows Kelvin waves, equatorial Rossby waves, etc., etc. We're not so much interested in that, but you can see it was right here, this black dotted line, that's the inactive phase of the MJO, and actually it started further back. We thought it started somewhere even back in here, and the reds and the oranges are westerly anomalies, and see, there wasn't a whole lot. There's little bits and pieces, but not a whole lot. But then here we get to, same deal, Kelvin wave generation area right down here, and these purple lines are the El Nino base state, if you will. Now notice it didn't disappear, but now with the active phase of the MJO right here in control, look at this, and there's a little bit of an equatorial Rossby wave going on here, and look at the deep reds here, and the scale on this is now, these are I believe these are in week-long increments here. So, 7 days, 16th of January, sure enough. So for the next 4 weeks, according to this thing, the active phase of the MJO is supposed to be in control, westerly anomalies in control. So the expectation is the storm machine will be in full gear. Now, the models that we're used to looking at here are having some difficulty. I'm sure that NOAA is working on it, but we'll step through it. The current state, you can't tell what it is, but the forecast per the statistic model, this is the active phase of the MJO, and it has it basically locked in this same position. Right here, it's at about 180, slowly easing east over the next 2 weeks, with the inactive phase of the MJO over India right now. At some point, this will probably move its way to the east and shut down the westerly wind machine, but the question is when and how. Now, here is the dynamic model, completely unreadable, but we saw it a day or two ago when this was still working. It had the active phase of the MJO holding, not moving as much to the east. But again, this is all nonsense here, so I can't really show it to you. But we can look at the phase diagrams here just as well. So this is, Indian Ocean here, the maritime continent. This would be like Indonesia type area. West Pacific here, the date line here, and then you move into the Americas and Europe, and then you come back around. The MJO travels this way around the globe. These are past measurements. This is monitoring where the core of the active phase of the MJO is, and these are like the 21st of December, 22nd, etc. Here we are, 2nd of January. We are in the West Pacific, and the further away from the center, the stronger the MJO is. So we're in a moderate strength per the ECMF model, and this has it moving fairly quickly to the east and getting weaker, where the dynamic model, well, again, it's not working, so the forecast isn't here. But here's a composite of a bunch of different models, and they're all basically showing the active phase of the MJO either maybe strengthening a little per the GEFS, or maybe weaker per the CANM. I gotta assume that's a Canadian model, but I'm not sure. But anyway, the point being, the active phase of the MJO for the next 2 weeks is to hang in this area, working slowly east. So here's the CFS long-range model. Now things are a little different here. We're going back in time. The bottom is back in time. Kelvin wave generation area pretty much right down in here. We had our last big westerly wind burst was right up in this area here till about October. Then we went into the inactive phase of the MJO, and you can see it definitely here. And now here's where we are in the middle of a major westerly wind burst. Let's overlay the MJO. Here you go. You can see it. There's the inactive phase, the dotted lines. And the active phase tried to come in, but it never really got footing until about, right about the end of December or so. We're right in the thick of it now, and the expectation is this is going to continue in some form probably out till the end of January, which is consistent with about a standard active phase life of about 4 weeks. Now, and that's good. Lots of westerly winds here. That should be feeding the jet stream. Again, we're not talking so much about Kelvin waves because there's not so much warm water over in that area. Most of the warm water that's been in the West Pacific has been pushed east, and that's what El Nino does. It flips that. Normally warm water's over here, cold water's in the east. When you get into El Nino, you get these westerly winds. It takes all the warm water over here, pushes it this direction, and then you end up with cold water over here. Again, this chart does not represent that. I'm just figuratively pointing that out. Anyway, so westerly winds to continue because westerly winds feed the jet stream. That feeds the storm track. That's what we're interested in at this point. Okay, little bit of a back off here. Basically, the whole month of February looks like it's be a write-off with the inactive phase of the MJO in control. The theory has always been that during strong El Ninos, the MJO disappears. Well, that's clearly not the case in this year's El Nino. One for the lesson books, I guess. Another theory will have to come and explain why that is not, the normal pattern didn't set up, but it is what it is. That's why sometimes you can't always believe the models. You can't always believe the theories. You always have to hold a little bit out to say, it just sort of does what it does sometimes. We learn from it. We try to examine it and understand it, but we don't know everything. Anyway, so we get into the March time frame. The active phase of the MJO is to return. Westerly winds to, again, build up. One would expect another dose of weather and swell in association with that. Now, we can also add on equatorial Rossby waves. The interesting part here is little bit of a Rossby wave here, but it's not quite showing up like it did in one of the previous charts. So we're supposed to be in a Rossby wave right now under the influence of it, but it's not showing. Anyway, and then of course low pass. This shows you the strength of El Nino. El Nino, per this chart, peaked out about October 30th, but that's just one little dot. I mean, notice it's supposed to stay very strong the whole way into April. This is a global weather pattern. Once the global weather pattern is shifted, it's like a very big boat. It takes a long time to turn it off. Even after we get into the spring time frame, this pattern will still, just on momentum along, keep going, probably well into summer or next fall. We would expect a pretty strong storm track all summer long in the southern hemisphere, and then probably start out with a pretty strong start to the fall season, but then the later part of winter of next year, things will start falling apart as we expect a La Nina to set up, and that's typically what happens after El Nino. So we've talked about winds up at the surface, the MJO, what's going on with all that. Westerly winds, remember we were talking about westerly winds take warm water in the west, and this is in the West Pacific, this is the East Pacific. Push it to the west. Clearly you can see that 30-degree temperatures, absolute temperatures here across the dateline when normally they'd be holed up over in here, off in the far West Pacific. They're over the dateline, working their way to the east. The 28-degree isotherm, this is pretty much the standard for measuring how far warm water moves, is right at 122. It was at 120 for a while. It's backed off a little bit, not surprising with the effects of the inactive phase of the MJO. And then here you go. This is anomalies, differences in normal for this time of year. Notice cool water at depth here really set up in the West Pacific and working its way well to the east underneath the El Nino supported warm pool here. Westerly winds took warm water, push it to depth, create a Kelvin wave. Well, this isn't a Kelvin wave. This is a reservoir of warm water that's been created by basically a year of westerly anomalies. It's kind of weakened off. It was up to 7, almost 8 degrees at one point now. Now it's just down to 5 degrees above normal, but still lots of warm water from the dateline east, and with westerly anomalies blowing, whatever warm water is left is going to continue to get forced here to the east. But again, it's not about creating Kelvin waves anymore. This is all about just driving the jet stream, driving the storm track now. So the reservoir basically is discharging here. There just isn't enough warm water left over here to keep driving it to the east, but still not bad given the time of year. Here's another view, same sort of picture. This is the high-res GODS image. Cool water, you can see infiltrating well underneath the warm reservoir, but the warm reservoir is still there. Two little finger here of 4-degree anomalies poking up at about 110 west. Another little pocket here at about 95 west or so. Warm water working its way into Ecuador, but not reaching the coast. Again, westward displaced. That's just the character of this El Nino. It is what it is. But whatever warm water is here will continue to feed into the reservoir. But if you saw the time-lapse loops of this, and you can see it on the site, you can see this pocket is getting progressively smaller, and these cooler waters are working progressively east. We believe the upwelling phase of the Kelvin wave cycle, that is cooler water, at some point will make an appearance here, but with all these westerly anomalies, that should be stomped out pretty soon with maybe something that vaguely resembles a Kelvin wave showing up 2 to 3 months down the road. Upper ocean heat anomalies, we like this chart. You can literally see Kelvin waves, after the fact, Kelvin waves migrating across the Pacific, West Pacific here, East Pacific here. This was the upwelling phase of a Kelvin wave, previous Kelvin wave last year. Then we got into 2015, Kelvin wave number 1 in the spring, Kelvin wave number 2 in the early summer, massive Kelvin wave number 3 that occurred in the July-August time frame, and then an even larger Kelvin wave number 4 in the October-November time frame. It has pretty much, so starting here about sometime in December, it started losing its ability to warm the surface waters, and it is slowly fading out. You can see all these warm temperatures retreating to the east now. Still, this base, what is that, 0 to half a degree above normal, is trying to hold on. Westerly anomalies trying to push whatever warm water's left to the east, but the short of it is the warm water pool in the west is pretty much tapped out. Maybe we'll get another Kelvin wave, but maybe all these westerly winds, again, like we said, they're just going to fuel the jet stream, which is all we're really looking for anyway. So it is the subsurface, so it's westerly winds push warm water to the east, which fuels a subsurface warm pool here, which then erupts to the surface and warms surface temperatures here. And so we're looking at, these are differences in normal for this time of year. Clearly a very solid El Nino warm surface pool present with a couple little pockets of 4-degree anomalies here. Not nearly as strong as it was a month ago or so, but still solidly impressive. The other thing to notice here is cool water is again starting to show up now north of Australia. That's what we want to see. We want to see high pressure building here, but cooler water, that would be a classic kind of El Nino setup, is cooler water here, warmer water here, and that's what we are seeing. Let's dive into the details. We'll go very quickly here, sector by sector. Temperature anomalies, warm water here off of Ecuador, nothing super impressive compared to a week ago. Maybe a little less impressive, if anything, but building here up into Costa Rica, that area. So, but this Nino 1.2 region has not been the focus of activity for this El Nino, so we're not so concerned with it. Looking at the next sector to the east, out to 160 west, lots of warm water. Now going back a week ago, a little bit more width and a little pocket of 4-degree anomalies here south of Central America. It's still there, not super impressive, but actually there's more width out in here, and this is the Nino 3.4 region, starts at 120 and goes out to 170. Main El Nino monitoring area still looking very healthy indeed, and we don't expect that to change anytime soon. And then finally, the last sector going from 160 out to 170. This is the end of the Nino 3.4 region. Very healthy, very warm water, 2.25 degree or better anomalies out to here. Compared to a week ago, basically this area is holding, I'd say, about steady with a little bit of hanging out even past the date line. Very impressive indeed. A very solid El Nino based on these water temperatures. And then finally, looking at the mid-zoom image, we see a small pocket of 4-degree anomalies here just south of Mexico, and another small pocket just west of the Galapagos. But compared to a week ago, the pattern was a little stronger. All this suggests is that the subsurface warm pool is slowly draining, and so that reflects a weaker warm pattern at the surface as well. We're past the peak. Basically, the peak happened in the November time frame. Maximum warming was then. And in fact, here's the image for that. You can see much more 4-degree anomalies with 5-degree anomalies embedded in there. So things have settled down considerably since then, but still very respectable pattern. Much ability to influence the atmosphere with this warm pool here. The trend over the past 7 days shows little pockets of warming pretty well off the coast here of Chile and Peru. A little bit of warming west of the Galapagos, but otherwise, and a little bit here south of Central America. But for the most part, no clear signs of any major warming going on in the Nino zones. Looking at the trend in each of the zones, you can see clearly temperatures are dipping in the Niño 1.2 region. Actually, a pretty steep dip just in the past day, down to 1.5 degrees, where it had been hovering in about the 2-degree range. But that's really not a concern because, again, that has not really been a contributor at all to this El Nino the entire time. Now, more interesting, the Nino 3. region, that's west of the Galapagos, is just holding quite steady, 2.5 degrees, and has been in the 2.5 degree range or better now for, since October. So October, November, December, 3 months or so. That's very, very good numbers. And then finally, the Nino 3.4 area, the main area that NOAA uses to monitor El Nino. Again, a slow, steady decline commensurate with the discharge of the warm pool subsurface at plus 2.374 degrees. But basically, again, in the 2.2 range or higher for the past 3 months. This is biased maybe a little bit high, but still indicative of a very strong El Nino. We're not going to declare a super El Nino. We'll let NOAA do that. The MEI index would probably be the best way for that to happen, and that should be updating in the next several days. So then we'll see where we're at, have a much better sense. But clearly, this is looking like one of the top 3 El Ninos in modern history. So we've looked at winds in the Kelvin wave generation area. We've looked at the effects of those winds in terms of pushing warm water to the east. We've looked at the subsurface warm pool off the Galapagos and saw that it is shrinking. We've looked at the surface, the result of that erupting subsurface warm pool, and seen that there is a clear El Nino, strong El Nino signature, but it too is fading a little bit. But then ultimately, what matters is the effect of that warm water on the atmosphere, and so we'll look at a couple indexes here. Of course, the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Long run of negative numbers suggests El Nino, or at least the active phase of the MJO, but we've been negative, so we went through a bit of a positive spurt here in December until about right around Christmas time, a little bit after Christmas. This was the final end of the inactive phase of the MJO. Now we've just been rock solid in the minus 20s. Today's value is minus 33.9. Notice we were at minus 38.5 just a day ago. That's taken the 30-day average. It's starting to make the turn to negative, towards going negative again, minus 9.47, or I should say going more negative than it was before. It's been negative, but really the inactive phase has taken a hit out of it. We want to see this down at about in the minus 30 range where it was at one point, but it's lost a lot of ground. But as long as this active phase of the MJO hangs on for a month, this should also return to pretty steep negative numbers. The 90-day running average, minus 10.94. We want to see this in about the minus 18 range, minus 15 to 18. And we suspect we'll probably get there. Hard to say, but at least we're on the right track again now. And similar to the Southern Oscillation Index is the ESPI index. Rather, though, than measuring differences in pressure between one region over Darwin and Tahiti, it's cloud cover. Positive numbers represent El Nino. We're at 1.98. We've actually are getting better coverage, more clouds in this region, exactly what you'd want to see during a El Nino activity. So we're gaining ground again indicative that the active phase of the MJO has taken over this main region here. And this is really the index we're looking forward to seeing what impact it has. There should be updating this in the next 2 to 3 days. Back in December, the November reading had it, well, here is the 97 El Nino in red, the 82, 83 El Nino. These are at +3 standard deviations from normal. We do not expect that this year's El Nino will reach the 3 standard deviation mark. It'll probably get up into the 2.5 or so and put it comfortably in position number 3 of all El Ninos since I think it was about 1950 is when this started. This is a good measure. It's not only the Southern Oscillation Index, but also a host of other variables all combined. So it's a well-rounded index to sort of get the holistic view of this El Nino as compared to previous El Ninos. And again, at a position somewhere in the third strongest in the past 65 years, that is not a bad place to be. And the surface Nino 3.4 sea surface temperature forecast, this suggests that we peaked in the early November timeframe, which is about right. Actually, what we calculated was somewhere around the November 20th is about when it peaked out, somewhere more over in here. But, you know, this is pretty close. And the forecast has it going down to 2.55 degrees in January, which is where we're at now, and we'll get a reading on that shortly. And then a steady decline from there. But according to this model, still not even getting back to normal temperatures in the September time frame. So, again, the warmth will continue to have an impact on the jet stream, which will continue to have an impact on global weather for some time to come. So to wrap this all up, the short of it is a very strong jet stream is in control right now. It is creating a series of storms that are scheduled to impact the California coast and track north of Hawaii over the coming week. The expectation is that is the first of maybe 2 to 3 to 4 weeks of a continued pattern like that. Much storminess likely, but maybe we'll get some breaks in there too. And that should continue through January, maybe a break in February, and then the whole machine ramps up again in March when the MJO turns active again. So pretty much it's as good as you can want for in terms of raw storm generation potential and also for producing precipitation. In fact, if you can look at this, east coast of the U.S., west coast of the U.S., this is the accumulated precipitation based on the GFS model through Monday, January 11th. Actually, it's 0Z, so that's Sunday night, a week from now. Rainfall totals along the coast, 5.7 inches, 5 inches, 5.1, 7.2 there in the Big Sur area, it looks like. And then good amounts of precipitation up into the Sierra. Now, this model does not really account for elevation effects, so much more precipitation up in this area in the Sierra than what's probably predicted here. So a good, healthy soaking looks predicted. And so with that, should help ease the constraint on water in the southwestern U.S. at least a little bit, and the hope is that we get 2 more weeks behind that of similar sort of situation. So not such a bad situation. Surf, not great, a bit stormy basically for many locations. Pick and choose where you go, play it safe, Water quality might suffer near major metropolitan areas. Use common sense, but it looks like there'll be no shortage of raw surf potential. Plenty of snow, plenty of rain as well. Now we're just waiting for a little bit of quality. Maybe almost too much of a good thing is what it looks like for the coming week, but that's certainly better than not enough. So that's it for this week. We'll do it again next week. Same time, same channel. Thanks so much.